summation of all the forces must be equal to 0. So how to check it? Either you can go for, how to check it? You can go for analytical method or you can go for graphical method. Graphical method, so if the system is in equilibrium, summation of all the forces must be equal to 0. That is the condition. So how to show it in a graphical method? By drawing a force polygon. Drawing a force polygon. You know the magnitude of all three forces, F1, F2, and F3. F1, F2, and F3. If you draw the force polygon of F1, F2, F3, if it is a completely closed, then you can say it is summation of all the forces will be equal to 0. If it is not closed, you can say it is not equal to 0. So first thing, draw the force polygon. So the force polygon. So how to draw the force polygon? First, we need to draw F1. What is the direction of F1? You know the magnitude. You can take a proper scale. So this is F1 from point O. This is A. F1. Next, what is F2? F2 is here, right? F2 is here. Okay, let it be. F2 is here. I'll take it as just a minute. Okay. F2. Just a minute. I have a call. Okay, so force polygon, let us draw first one F1. So I'm going to draw F1. F1 is somewhere here. This is F1. And you know the direction and magnitude. Magnitude, you take a length, and direction, same as this direction. Okay, I think it is not proper. I'll draw this again. Okay, so this direction, the direction is like this, right? So you can draw on the same direction. So I'll draw this. Yeah, so this is what F1. After that, O, A. Next is F2 is directly upward, right? So you take a magnitude and draw it. This is F2. This is B. Next angle is 90 degree, right? So 90 degree. So the next thing is F3. F3 is parallel to F3 from this point, from B. So it must be close, means the end point of F3 must be on O. Then only you can say it is static equilibrium. If it is not closed, if this point, end point of F3 somewhere here or here, then you can say it is not an equilibrium condition. So if this condition is satisfied, you can say it is in a static equilibrium. So second condition should be satisfied in a graphical method. First condition can be satisfied with the help of analytical method. Analytical method means you need to split this F1, F2, F3 into horizontal and vertical component. You add the vertical component and add the horizontal component. Okay, so then we'll get horizontal component and vertical component, and you can find out the resultant of that. Resultant is equal to square root of vertical component plus square root of vertical component square plus horizontal component square, and angle can be found, that is theta is equal to tan inverse of FB by FH. So that method also you can go for to find out the or to satisfy the first condition. Is it okay? But this is the graphical method is somewhat easy compared to analytical method, because analytical method it takes lengthier calculation, so it takes time. Are you clear? Any doubt in this? Any doubt? Can anyone speak, please? Figure A, figure B. So write down, this is point of concurrency. Point of concurrency. Am I audible?
Yes, sir.
Okay.
Yes, sir.
Okay. Any doubt, please? If you have any doubt, please ask me this, because this is very useful in the problems, because we are going to solve the problems on equilibrium of 2 force member, equilibrium of 3 force member. Okay. So this concept is very, very important. This concept will be used to solve the problem. If you have any doubt, please, you can ask. I can explain it once again. Don't hesitate. Please, if you have any doubt, you can ask. Finished? Hello?
Yes, sir.
Force polygon must be closed, right? Or summation of F is equal to 0. Please write down. Force polygon must be closed for summation of all the forces equal to 0. If you want to satisfy this condition, if you draw the force polygon, it must be closed. Finished? Okay, let us go to the next slide. Okay, so next, case 1. Case 1 for the same condition. Okay. Otherwise, yeah, write down. Case 1. Let us take a figure like this. Okay, a body. Let us have 3 points. One is here, another one is here, and third one is here. Okay, point A, B, and C. Okay, so the next is the forces. I have F1, F1. I have F2 here. Okay, or F2 somewhere here, and F3 somewhere here. Okay, F3. Okay, now so I have to check whether the body is in static equilibrium or not. Case 1, check whether check the body is in equilibrium or not. Okay, so how to check this body whether it is in equilibrium or not? The first one, for equilibrium, static equilibrium, what is the first condition? First condition, summation of all the force must be equal to 0, or vectors force polygon must be closed. Force polygon must be closed, right? Closed. Second one, what is the second condition? The line of action must intersect at point of concurrency. Point of concurrency, POC. Okay. First, let us check whether the points or the force are acting on the same point or meeting at a point of concurrency. How to make it? You just extend F1. Okay. And just extend F2. Yeah, F1, F2 is intersecting at this point. And third first force also must be intersecting at this point, but according to the given problem, the force is intersecting somewhere here, not at the same point. So this point O1, this is O2, right? O1, O2. There are 2 points of intersection. So it is not a common point, it is 2 different points. So that's why you cannot say, or you cannot say it is in a static equilibrium. It is not in a static equilibrium. So for the first condition also, right? So if any one condition out of these two, one condition is not satisfied, then you can say it is not in a static equilibrium. If it is a static equilibrium, both the conditions should be satisfied. Write down below these two conditions, write down. The forces acting on a member, is not an equilibrium. The forces acting on a member is not in equilibrium as the line of action of the forces do not intersect at one point. So first you check whether it is intersecting at a point of concurrency or not. If it is not intersecting at a point of concurrency, you cannot, or no need to go for the first condition. Okay, so automatically first condition will not be satisfied if it is not intersecting at a common point. Okay. Oh, so this is the case number 1. Copied? Hello? Copied? Shall I go to the next slide?
Yes, sir.
Okay, thank you. So next slide, case number 2. Case number 2. Consider a member in equilibrium. Consider a member in equilibrium in which consider a member in equilibrium in which The force F1 is completely known. The force F1, capital F1, is completely known. Comma, F2 is known in direction. F2 is known in direction. F2 is known in direction only. And F3 is completely unknown. And F3 is completely unknown. F3 is completely unknown. F3 is completely unknown. This question is asked in previous examinations many times. If you see the previous question papers, very important question. Okay, it is the different case, or the it is uh, on the same principle of the members with the 3-4 system. Okay, it is just changed, and he has asked you to find out whether the system is in equilibrium or not. Okay, on the basis of that you can find out, or you can find out the direction of unknown force and magnitude of unknown force. F3 is completely unknown, but he's telling that it is completely balanced. Okay, only this sentence is given, you need to draw the figure your own. Okay, solution. What he is telling is telling that the body, let us consider this the body. Okay, according to the given condition, the system is in equilibrium. The first statement itself is in equilibrium. Okay, in equilibrium there are 3 forces. The first force F1 is completely known. Completely known means both the direction as well as the magnitude is known. There are 3 points. Okay, I'll mark 3 points B, C. First force. Okay, let us see. This is point C. This is point B. Okay. Okay. First force F1 is completely known. Completely known means it is known in direction as well as magnitude. Known in direction as well as magnitude. Let us consider. So I'll draw somewhere here. Okay, it's left to you. You can draw in any direction, but it should be known. Okay, so this is the direction F1. I know the direction. I know the magnitude of F1 also. Okay. Second one, F2 is known in direction only. I don't know the magnitude. I know the direction. Is it okay? I don't know the magnitude, but I know the direction. So F2 is acting on point B. Let us consider. I know the direction so that I can show like this. This is, yeah, this is the direction. I don't know the length. Okay. I don't know the length of this force, but I know the direction. Is it okay? Okay, I think you're understanding the concept, what I'm explaining. Don't get confused. If you have any doubt, you can ask. No problem. Okay, so don't keep the doubts with you. You can ask the doubt so that I can clear it. I can clear it. Okay, sorry for the disturbance. Okay, so next is F2. F2 is acting this point. I know the direction, both the direction as well as magnitude. But here I know the direction, but I don't know the magnitude. Okay, I don't know the magnitude. Okay, so next is the third force, completely unknown. I don't know the direction, I don't know the magnitude. Okay, so I'll show this third force like this. So what is the indication of this one? I don't know the magnitude, I don't know the direction. Is it okay? So zigzag line indicates it is known, it is unknown in magnitude as well as direction. Is it okay? Please don't get confused. Should know. Now onwards, I'll use this notation for unknown force, both in magnitude as well as direction. Is it okay? So this is what the given condition in the problem. Now, actually, this is not a problem. It is the basic principle or the basic principle. It is a sub question. Okay. Okay. Next is, so how to prove this, or how to identify the unknown force and unknown magnitude. I'll convert the same figure. Go to the next figure. I'll draw it once again. The same figure you need to draw, but it is very difficult to copy the same figure. Please. Similar figure draw ಮಾಡೋ ಸ್ವಲ್ಪ ಕಷ್ಟ, ಆದ್ರೂ ಮಾಡ್ತಾ ಇದೀನಿ ನೋಡಿ. ಸ್ವಲ್ಪ ಚೇಂಜ್ ಆಯ್ತಂತ. Okay. Okay. Okay, same figure. So it's somewhat a little bit larger. Okay, please adjust to that. Next, I'll mark the same point somewhere here. A, B, C. Okay. Okay. So the next figure, I have first I need to mark all three forces which is known, all the forces which is known. Force F1 is known, so I'll mark F1, and I need to extend this F1. I need to extend this force F1 because what is the condition? If it is an equilibrium, he is telling that it is an equilibrium. So what is the condition satisfied for the equilibrium? Point of concurrency, right? That is the first condition. So I have to extend it to the next end. Next, I have to show the second force. F2 is known in direction, right? I don't know the magnitude, but I know the direction. So I'll show it. So this is F2. F2, I'll extend this and I'll try to intersect the first line. Correct? So this is what the point of intersection. Next, the third force, I don't know. I don't know the direction, because if you know the direction, you can directly draw, but I don't know the direction of the third force, right? I don't know the direction, I don't know the magnitude. Forget about the magnitude, but the direction is important in the first condition. Okay. Okay. So what I'm going to take, I'll take this point. But what is the condition? It is in a static equilibrium. So if it is in a static equilibrium, what is the condition? First condition, summation of all the force must be equal to 0. Second condition, what it says? Second condition, point of concurrency. Point of concurrency means all three forces must be joining at the same point, common point. So here, these two forces are meeting at a common point. What about third force? Third force is also intersecting on the same point, or it is passing through the same point if it is in a static equilibrium. It is saying that it is in a static equilibrium. Always the third force, you can show it So third force is also passing through this point. First, you need to draw the line through this point C to O. This is, let us consider O, okay, point of concurrency. So you just join this, okay. So after that, on the same line, you need to draw the unknown force. Unknown force. So this is what the direction. So by this, you can say it is acting on this direction, F3. I don't know the magnitude, but I know the direction now by applying second condition. If you apply the second condition, you can find out the unknown direction. So this force is acting in this direction. In the second step, we'll get the direction of F3. The second step will get the direction of F3. Now, I don't know the magnitude. I know the direction, but I don't know the magnitude. Here, I know the direction. I don't know the magnitude. Here, I don't know. I know both magnitude as well as direction. In the second step. But first step, this case, we don't know magnitude as well as direction. But here, in this step, we know the direction, but we don't know the magnitude. Copied? Hello, copied?
Yes, sir.
Okay, third step. This is step 1, drawing the figure. This is step 2. Step 2, second condition. Step 3, force polygon. How do you find out the unknown magnitude? Here there are two cross symbols, right? One is this one and the second one is this one. What is this cross symbol says? The magnitude, right? The first symbol says direction, second symbol says magnitude. So I don't know the magnitude of F2 and I don't know the magnitude of F3, correct? So how do you find out the unknown magnitude? By force polygon, by force polygon. So you can draw the force polygon. F1 is known, F1 is known. So I'll draw the force polygon F1, F1 at the same direction, F1, OA. I know the length of F1, right? I'll get a point A. OA length I know because I know the length of F1. I know the direction of F2, but I don't know the magnitude. So direction, if you know the direction, you can draw, right? So just draw a line from A. I don't know the length. You can draw any length, no problem. Correct? You can draw any length. So this is F2. I don't know the length. That's why I have drawn a long line. I don't know the length. So that's why I have drawn a long line. Next, F3. I know the direction. You just make a parallel line to this F3. Parallel line to F3. But he is telling that in the condition it is in a static equilibrium. If it is in a static equilibrium, what is the first condition? Summation of all the force must be equal to 0. That indicates force polygon must be closed. So force polygon close agbekantanದ್ರೆ we need to have any point somewhere here. I don't know where exactly that point because I don't know the length of F2. But if you take any point and if you draw a line, it has to cross this point O because it must be closed triangle, right? So I have to draw a line which is parallel to F3. F3 is here. I'll draw a line F3. So it will intersect somewhere here. So this is what my F3. So I'll get an intersection point. That point is B. Is it okay? That point is B. So now if you take the length of F2 will gives you the magnitude of F2. If you take the length of F3, that is OB, will get the length of F3 or magnitude of F3. This is how to solve this problem. You need to show this figure and explain it. So we'll get 6 or 8 marks. This is 8 marks question actually. It's asked many times in the examination and it is very important concept also. Okay, and this question will be asked in the gate examinations, competitive examinations. Okay, very important concept. Now I know the magnitude of F2 and F3. I know the direction of F2 and F3. What is asked in the question? Copied? Below this figure, you can write down, please. I have an explanation for this one. You can copy this. Please, once you finish, let me know. Start to dictate. Okay, write down. The point of application of F1, F2, and F3, the point of applications of F1, F2, F3, and F3 are A, B, C respectively. Are A, B, C respectively. Capital A, capital B, capital C respectively. Full stop. To solve this problem, first, first find the point of concurrency O. First find the point of concurrency O. First find the point of concurrency O, capital O, from the two forces with a known direction. 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 That is from F1 and F2. That is from F1 and F2. Full stop. Full stop. Joining O with C, joining O with C, joining O with C gives the line of action of the third force F3. Gives the line of action of the third force F3. Full stop. To know this magnitude, to know the magnitudes of F2 and F3, to know the magnitude of F2 and F3, take a vector of proper magnitude, and direction, vector of proper magnitude and direction to represent the force F1. To represent the force F1. Force F1. Okay. Full stop. From its two ends, draw a line parallel to the line of action of the forces F2 and F3. Draw a parallel lines of action of the forces F2 and F3, forming a force triangle. Forming F2 and F3. Mark the arrowhead on F2 and F3. so that F1, F2 and F3 are in the same order, so that F1, F2 and F3 are in the same order. Same order, full stop. So that is the end of the second case. Next is note. Note below that, if line of actions of two forces are parallel, if the line of action of two forces are parallel, if the line of action of two forces are parallel, the point of concurrency, lies, at infinity, and therefore the third force is also parallel to the first two at infinity, and therefore the third force is also parallel to the first two. Finished? I repeat, if the lines of actions of two forces are parallel, then the point of concurrency lies at infinity, and therefore the third force is also parallel to the first two. What it indicates, the note. So if you have two forces, let us consider this is F1 and F2. This is F2. These two forces are parallel, okay? So where is the point of concurrency to this force? This is point number A, point B is acting on point A, point B. So how do you find out the point of concurrency or point of intersection? By extending this line. But if these two lines are parallel, automatically the extension line or the line of action is also parallel. Where it intersects at infinity. Okay. If you have a third force is also parallel. Okay. So if you have a third force in a system and it is also intersecting at infinity, let us consider this is F3. F3 is also intersecting at infinity only if the body is in equilibrium. It is in a equilibrium. Is it okay? That is the meaning of that force or that sentence. Okay. So no need to worry about that. That we will discuss in the while solving the problem. Okay. Any doubt? Hello. Any doubt?
No, sir. Sir.
No. Let us go to the next slide. Okay. Member with case number 3, right? Member with, not case number 3, that is a main case. Member with two force and a torque. We have a body with two forces and one torque. Write down below the heading. A member under the action of an applied torque. A member under the action of applied torque and two forces. Applied torque and two forces will be in equilibrium. If the first condition, write down. First condition, if condition number 1, the forces are equal in magnitude. But parallel and opposite to direction. The forces are equal in magnitude but parallel opposite in direction. That is the first condition. The forces are equal in magnitude but parallel and opposite in opposite in direction. Second condition, the couple formed by the equal and opposite forces, the couple formed by the equal and opposite forces is in the opposite direction, is in the opposite direction, is in the opposite direction of the applied torque, or torque is nothing but couple, right? Couple. And equal in magnitude and equal in magnitude. If these two conditions are satisfied, then you can say the system is in equilibrium or a static equilibrium. Finished? It's time up. Do it fast. We have another 4 minutes. Finished?
Yes, sir.
Okay, let us go to the next slide. I'll explain what is the meaning of this sentence. Okay. So let us consider we have a body. Okay. Okay. So we have 2 points. Let us consider point A and point B. Okay. This is point A and this is point B. Okay. So this body is experiencing 2 forces. Let us consider one is here. This is one force. Okay. F1. And I have another force which is parallel to this force. Okay. F2. These 2 forces are parallel. Okay. And it experience one more component is that is torque. Let us consider this torque is like this. This is what applied torque T. So the body is experiencing 2 different forces at 2 different points, and we have one couple on this body. Now, how to make it a static equilibrium? How to make it a static equilibrium? What is the condition for static equilibrium? First condition, the forces are equal in magnitude but parallel and opposite in direction. If you apply 2 forces on a body, these 2 forces must be parallel to each other. Parallel draw and I have drawn parallel only. But parallel, but opposite. It is not in the same direction. Not only parallel, it should be opposite to each other. Right? It is opposite direction, right? Opposite. And parallel and opposite. See, parallel and opposite in direction. That is the first condition is satisfied. Second condition, if let us consider I have a body, this is the body, one force is acting like this, another force is acting like this. What happens? F1 and F2. What it says, the forces are equal in magnitude. F1 must be equal to F2. This is the first condition. Equal and opposite and parallel. 3 conditions should be satisfied. First one, equal. Second one, parallel. Third one, opposite. These 3 cases are satisfied for the first condition. F1, F2 are equal and it is opposite to each other and it is parallel to each other. Is it okay? First condition is satisfied. Second condition, torque formed by these two forces. Let us consider we have F1 and F2. F1 and F2 both are equal and it is acting on the same body at two different points. What happens? It will make some couple, right? The couple will be like this. What is this couple magnitude? Couple is equal to F1 or F2 force into the perpendicular distance. How do you find out the perpendicular distance? You draw a perpendicular line to any one force to the second force, line of action of the second force. This is what the perpendicular distance. Let us consider this is H. F1 into H. It is equal to F2 into H because F1 is equal to F2. So this is what the couple formed on the body. This is a new couple, okay? This is the couple formed by F1 and F2. This is the torque applied. What is the second condition says? The couple formed by the equal and opposite forces. What is that couple? C. This couple equal and opposite of the applied. Sorry. The couple formed by the equal and opposite forces is in the opposite direction of the applied couple and equal in magnitude. What is that? Applied couple is T. It is the formed couple C must be equal and opposite. See, this is what C. It must be C must be equal to T. Both in magnitude as well as direction. So direction is opposite, but magnitude should be equal. Is it okay? So that is what the meaning. Please copy this figure, and I'll give you the sentence. Copy this figure. So I'll extend time up, do it fast. Okay, so this is what H perpendicular distance. I'll draw the perpendicular distance. Okay, this is what the perpendicular distance, perpendicular line H. Okay, so this is what H perpendicular distance. Okay, write down couple is equal to couple formed by F1 and F2 is given by C is equal to F1 into H is equal to F2 into H, because F1 is equal to F2. Therefore, for equilibrium, second condition, what it says, second condition, equilibrium, C is equal to T is equal to F1 into H is equal to F2 into H. And what is the couple direction? Counterclockwise. This is counterclockwise, okay? CCW. T is clockwise. It is given in the figure. Time up. Do it fast. Write on below that sentence. Where T, F1, F2, where T, F1, F2 are magnitudes of magnitudes respectively, T is a clockwise, capital T is a clockwise, whereas the couple formed by F1 and F2, within bracket C, whereas the couple formed by F1 and F2 within bracket C is counterclockwise. Finished? Whereas the couple formed by F1, F2 is counterclockwise. So I'll explain it once again within 1 minute. Look at this. So the member with two forces and one torque. I have applied two different forces, F1, F2 and T on the system. Now I have to make this system in a static equilibrium. What is the condition to be followed? First condition, the forces whatever we have applied on this body, F1 and F2, must be equal. It must be equal and parallel and opposite. These three conditions are satisfied. So I'll draw a line F1, F2 equal, magnitude is equal, and opposite and parallel. So I have drawn parallel and opposite direction. That is the first condition is satisfied. Second condition. So if two forces are equal and opposite and it is parallel and are acting at a different point, then you can say there is a couple formed. That couple formed is C. C is equal to F1 into perpendicular distance, perpendicular line. If you draw a line perpendicular to the F1 and F2, the distance is called as perpendicular distance. The force into perpendicular distance is equal to the couple C. F1 is equal to H or F2 is equal to H, because F1, F2 is equal. That it is given in the first sentence itself, right? So the couple formed, the direction of the couple is counterclockwise, because so it is the force F1 is like this, F2 is like this. So it is a couple counterclockwise direction. Okay. So the second condition, what it says, the couple formed by F1 and F2, which is C, is in opposite direction of the applied couple. Applied couple is T, right? So C must be opposite to F. It is always opposite because it is counterclockwise, and it should be opposite to T, and magnitude is same. T is equal to C. T is equal to C. Is it okay? This is what the third condition. Thank you. I'll take attendance. Those are